Um, I can say the prayer.
Okay.
Dear Heavenly Father, we're grateful for this day. We're grateful for all of our many blessings. Help us to have a good day. We're grateful that we're able to meet as a group. Bless Chris that he can join with us a little later, or that he'll be with us next week or later in the week. We love thee and say this in the name of Jesus Christ. Amen.
Amen.
Okay. See if there's anything specific we have to go over. How did the test go for you?
Not too bad. Did get on the multiple choice, so I'm not sure about the written part yet, but
Uh-huh.
yeah.
I did all right. Not as good as I'd hoped for the multiple choice part, but still pretty good. Um,
I haven't really had a chance to go through that prep activity, but
yeah, I haven't either. I did a little bit, but not as much as I'd hoped.
there are something, I understand most of this, but I'm always running into something that's confusing.
Right, yeah.
Huh. I'm just looking at the use substitution. I've never seen that before.
Hmm. Yeah, I've never used substitution for these kind of problems.
Oh, interesting.
Oh yeah, that's really weird substitution thing.
Yeah, I've never seen that before.
Yeah, me neither.
You just at the end, it would be 12 times 5x minus 1 squared. I don't understand.
Yeah, I don't get that either.
You plug 5x minus 1 back in and then solve it for x.
Yeah, that's what it looks like. It seems more difficult to do it that way, though.
Right?
That's so weird.
I guess it's just showing that there's other ways.
Yeah, yeah. Huh. Yeah, I don't think I'm ever going to use that throughout the semester.
Yeah, I'm not really sure. I don't see how that worked for them. So they just keep popping off.
No worries. It just seems like they're using it to make it look easier, but it's literally the exact same thing you would do using the 5x minus 1.
Right, exactly. It's just 5x minus 1.
Yeah,
So at the end,
so weird.
so they multiplied it out to get rid of the, yeah, to get rid of the fractions.
Uh-huh.
Then it just leaves. So how do they come up with 3 over 20 and 4 over 15? That's what I'm not seeing.
Um, it must be like when you factor it all out,
Uh-huh.
that's what you get at the end, maybe.
Oh, I guess that's I always forget that about these. After
Yeah.
you factor it, it all makes more sense.
Hmm.
Yeah, I'm not sure on this one. I have to go watch the videos or something.
Yeah, I don't know how they got that for the end equation.
Because if you threw 5x minus 1 into that, it'd be 12 parentheses 5x minus 1 squared.
Right.
And then it's still 5x minus 1 plus 1 equals 12 parentheses 5x minus 1 squared.
Yeah. Yeah, I don't get that.
I'm not sure, but
Yeah.
So it would be 5x minus 1 plus 1 would just become 5x on the left.
Yeah.
And then do you distribute the 12 or do you distribute 12? Minus 12.
I factored it out first and then times the 12 in.
Factor it out. Okay. So it became 5x squared minus, or 25x squared minus 10x. Wait, let me see that. Plus 2 after you factor it out.
Yeah.
You factor your 12 out into that. So 300x squared minus 20x plus 24. And then would you just divide that all by 5? No. How do you get all your x's on one side?
Well, you can combine the 120 and the 5 for 125. And then I think you move the 300 over to that side as well. But I'm not sure how you would, or how the x squared on that.
Right? Do you just pull an x out of the first two?
Right. Yeah, just factor out an x maybe.
And that would give you, they come up with 30 over 20 and 4 over 15.
3 over 20.
Do we have to square it? You know how they, no?
Yeah, I'm not sure.
A little tricky.
Yeah.
Just want to try some of the other ones.
Yeah. Let's see that.
Zeros for this? Is that what we're doing?
Yeah.
So do we set it to 0 first?
I believe so. Yeah.
And then it'd be P over Q, which is over 1. And we find all different factors. Is that right?
Yeah.
So I found 1 is one of them.
Mm-hmm.
I want to do it. No, no. Please. No.
So after you do that, do you take the -3, the 4, the -12, and that's how you number the remaining 2?
I think so, yeah. Just like separate them out.
What do you do when the lead coefficient is greater than 1? Do you just, isn't there something to that? I can't remember.
I'm not sure what you do with that. So I got 1 and then 1/12, 1/6, and 1/2.
How are you getting fractions on that one?
Using the rational roots theorem when you do like P over Q.
Uh-huh.
And
So you
you
12 over 1?
yeah, I got 1/12.
Oh, okay. Is it 1 over 12 or 12 over 1?
I'm looking at one of the examples from last week. And
Uh-huh.
it takes the end number, and puts it over the x. So you're right, it would be 12/1.
So fractions aren't in this one.
So 1/12, 6, and 2.
Uh-huh. And 3 and 4.
Oh yeah, 3 and 4, yeah. Yeah.
Yeah, that's right.
Okay, sweet. So for this next one, are we doing the same? Um,
The
same
x to the
thing?
fifth.
Yeah.
I think so.
Okay.
Well, yeah, oh yeah, we just have to make sure we fill in all the missing.
Right.
Kind of trick us. Two over one. All the vectors of one and two, and one. Do you use the synthetic vision?
I don't think you would for this one.
Okay. Yeah, there's just a couple steps of these I'm just not super sure about.
Yeah.
So what are you using for this one?
Um, I was thinking about using the same equation, but I'm not sure how it would work out since we don't have like an n number. It's just like equal to 0.
Uh-huh.
So I'm still thinking about what.
What the step would be on this one.
Right.
Do we just make the remainders here for this one? Though?
Um, I was looking at the prep for today, and it talks about like the different types of things you look for. And for this one, since it's set equal to 0, we can factor out an x. Um, And then we could probably use the like quadratic equation. I would assume. Or like,
So it would become, you just factor out just one x.
yeah.
And we use the quadratic formula or the quadratic equation, you said?
Um,
Let's see here.
because we're not able to do synthetic division because we don't have it equal to. If we made it equal, it would be 0 over x. And that wouldn't work. So we can't use that. And you can't factor it anymore or take out anything. Um, or could we do like, is it completing the square where you do like the first number and the last number times together, and then if they're added together equals the middle term?
Oh, we're working on the second one, right?
Yeah.
The fifth plus 3x cubed? Okay.
Yeah.
Okay. I don't know. Could you do that since it's got 1, 2, 3, 4? To fill in the x that are missing. Since it's x to the fifth, you have to add in x to the fourth. X to the x to the third, then plus 2x.
Okay, so you just add them
Or if
in.
we're not synthetically divided, do we not have to do that step?
Yeah, I don't think you would have to if you're not doing the division.
Oh, okay. So that's just for the division. Okay.
I think so, yeah.
So we're just looking at it as is. And then once you factor out x, it became x to the fourth, 3x to the second.
Yeah, plus 2. Mm-hmm.
I was at that mixing. Okay. Yeah, we do it that way. But I mean, even we don't even need to do that because x to the second, plus 2 and or plus 3 minus 1 gives our no, sorry. Plus 2 plus 1.
Right.
X squared plus 2x squared plus 1. That's factor then, right?
Right.
So then would we need to take out another x or can we leave that squared?
I think you take another x
So-
out of the first section.
So it'd be 2 x's on the outside. So it'd be x squared, x plus 2, x plus 1.
Yeah. So,
Because it says x is 0 and then plus or minus I and plus or minus I squared 2.
Huh.
for the answer. 0, and then I read 2. 0 on any of those. Oh, I need to study more.
Yeah, so do I.
You want to try table this and see if we get Chris in later today or this evening or something? Or
Yeah, we can. I haven't. I sent him. I sent him an email, and I still haven't heard back from him.
Yeah.
So I'm not sure what's going on.
at least until we're maybe a little more prepared, so we're not just fumbling around.
Right.
I don't really feel like we're going to get much from each other. I don't have anything to offer. I'm really kind of confused. So
Right.
but I'm willing to try to meet up again if you want to.
Okay. Yeah, I know I'm going to DMV later today, but I'm not sure exactly what time.
I'm fine with that.
Yeah, seriously. So, but I'll send him a text message and see if he responds, and then I'll let you know.
Cool. I have lab from 3 to 6, so anytime this evening after 7 or so, I'll be free.
Okay. Sounds good.
Okay, thank you. See you, Joe.
See ya.